What happens if one end, an extreme end, let's say end B is hinged? Very simple. Without chord rotation, it's MAB is equal to MF naught AB plus 3I by L into theta. Chord rotation with differential settlement, additional term comes minus 3I by L into phi. Very easy. Can't be easier than this. And you can similarly write what happens when the left end is hinged. Right. We are now ready to apply whatever we've learned to example. We'll do several examples. Here's one example where, you remember we did example 7, this problem. Now we are going to look at that same problem and we say that theta B is known to settle by 5 mm and support B is settled by, okay. Let's take the same beam without any loads but with only support settlement. Okay. Support B settles by 5 mm, support C settles by 10 mm. So you've got two interesting problems. This is a problem of combined loading and support settlement. These are called known chord rotation problems. This is a load problem where you have only support settlements, no loading. We've already done this. If you had both, it's a superposition. Okay. Let's proceed with this solution. So this is our first problem. How do we proceed? Well, first find out the fixed end moment. Ignore it. Find out the fixed end moments. This is something we did earlier, we just repeated. Nothing new here. MFAB, MFBA, MF naught BC. You know exactly what's going on. Next, you write down the slope deflection equations. Slope deflection equations is exactly what we did earlier, except one additional term comes. Before that, let's write down the chord rotations clearly. Chord rotation for AB is clockwise, and you have to put the correct units. It's 5 mm and the span is 4 meters. So you should write this mm in meters as 0.005 meters divided by 4. Okay, that's the correct way to do it. And so your equations are MAB equal to MFAB plus 4EI by L into theta A plus 2EI by L into theta B minus 6EI by L into phi. Right? Where phi AB is known. Similarly, MBA is MFBA plus 2EI by L into theta A plus 4EI by L into theta B minus 6EI by L into phi. Next, for span BC, here we are going to take advantage of the fact that C is hinged. So we are not going to use theta C does not come into the equation at all. What is the equation now? MBC is MF naught BC plus 3EI by L into theta B minus 3EI by L into phi B. That's all. You need only one equation. We are done. You can simplify these and everything is now in terms of the unknown theta B. Go ahead now, write them in this manner. Now what is going to happen is, in addition to your fixed end moments, you have to add these effects caused by settlement. So next we will write the equilibrium equation corresponding to theta B, MBA plus MBC is 0, expand it, corresponding to theta C. That's all, only one equation. Solve it, find theta B, plug it into your slope deflection equations, you get your final end moment. Once you have your end moments, draw the free bodies, minus 174.75, minus 139.5, plus 139.5 and 0. Find out your shear forces, draw your shear force diagram, draw your bending moment diagram. You're ready.